This is the ARM bay, a 3D printable housing for an ARM SBC and an Ethernet switch that mounts in the 5.25-inch optical drive bay. In the previous video, I demonstrated the concept for a small ARM home server and I showed you the basics behind the hardware side of the ARM bay. In this episode, I'm gonna present what changed in the second version of the ARM bay and how I finally got it configured. Or in other words, what I'm running on it. The main issue with the V1 was my choice of the target platform I was planning on using. Turns out the support for the Orange Pi 4a in the upstream Linux kernel is not yet polished enough to use it as a home server. There are three major changes the V2 introduces. First, I dropped the support for the OP4a and instead I aligned the model for the Waveshare CM4 I/O base, a carrier board for the Raspberry Pi Compute Module 4. The reason is simple. The RPA CM4 has great upstream support and I've managed to get the beefiest version of it for an absolute steal. The second change is getting rid of the front panel and replacing it with a small OLED screen for displaying the stats. Finally, the last change is adding a hole for mounting an external Wi-Fi antenna. There is also yet another change you cannot see, and it is that I redid the model almost from the ground up. I did this for optimization and to change the layer order, so I can export templates. A template is simply a blank ARM bay body with cutouts for handles and rail supports. This is to make remixing the project for other types of SBCs and switches easier. If you want to have a go at it, the ARM bay project is completely free and the link to the Thingiverse can be found in the video description. Now that you have major hardware changes covered, let's talk about configuration. The system I'm running on my ARM bay instance is OpenMediaVault 8, installed on top of the Raspberry Pi OS Lite. I like OMV for its simplicity and that it just works. Starting from the OMV configuration itself, I've set up an SMB file share on the NVMe drive that's connected to the carrier board, as well as backup automation using their sync utility and wake on LAN. I configured it so that at midnight on the first day of the month, the main x86 host is automatically started, the data is synced over to the RAID 1 array, and on success the target is shut down. Yet another feature I enabled that comes as a plugin is the file browser. This is a lightweight web service that allows for browsing the files on the share directly from the browser, just like in a Google Drive. Another service I installed on the host that isn't officially supported by OMV is Tailscale, my VPN of choice. The VPN is absolutely crucial to have for a remotely accessible server. With it, I can access the ARM bay and its services no matter where I am and from all sorts of devices. The last type of services are Docker services. These run in containerized environments to keep the host in a clean state. I've got 4 of those. OLED stats. This one simply controls the OLED screen on the front. It displays CPU temperature, CPU usage, root file system usage, and RAM memory usage. Memos, a lightweight quick notes type service. I'm currently testing if I like it, as I have a tendency of leaving notes but forgetting where I left them. Caps. Caps is a Linux printing server for sharing the ink printer with other devices in my home network. It is so the printer is not tied to any particular device. ScanServe.js. ScanServe.js is also printer related. It is a web-based service for using the scanner that's built into my DeskJet printer. And that is all, folks, for this quick overview. My home server is as bare bones as it gets, but the point I'm trying to make is you don't need to overbuild your home lab setup for it to be perfectly functional. If you are interested in technical details, either for the ARM bay V2 or my OMV setup, check out my recent blog post I linked in the video description. The links for the ARM bay and previous post and video are there as well. Thanks, Timox.